Hi students, in this video we will discuss about introduction of chemical kinetics. This is Dr. R. Jalababu, lecturer in chemistry, SAIM Government Degree College, Thanuku. First of all, learning objectives of this video: introduction about chemical kinetics, types of chemical reactions based on chemical kinetics, rate of reaction, units for rate of reaction. So mainly chemical kinetics deals with velocity or rate of reaction, mechanism or pathway of the reaction, time required for completion of the reaction, and finally in the given time percentage of completion of the reaction. So based on chemical kinetics, chemical reactions are classified into three types. They are fast reactions, moderate reactions, slow reactions. Fast reactions, these reactions are completed very fraction of the time, that means 10 power minus 5 to 10 power minus 6 seconds. They are the very fast reactions. They are the reaction is completed instantaneously, very short time intervals. And second one is the moderate reactions. For moderate reactions, the time for complete the reaction, they are the intermediate time intervals. That means when compared to the fast reactions, these moderate reactions are slow. And the third one is slow reactions. Slow reactions, it takes longer time intervals to complete the reaction. So examples for fast reactions are ionic reactions. So ionic reactions are fast because in the reaction mixture, the ions are readily available to immediately react to form the products. And moderate reactions, covalent compound reactions are the examples for moderate reactions. So mainly the majority of the organic compounds are covalent compounds. So the organic compounds reactions are comes under the moderate reactions. So for slow reaction, the example is rusting of iron. So rusting of iron, so this is the takes more time to complete the reaction. So the next, for fast reactions, to determine the rate of the fast reactions, the relaxation techniques are used. And for moderate reactions, so these chemical kinetics methods. So general chemical kinetics is mainly deals with the moderate reactions. For slow reactions, radioactive methods are used. So then, what is the rate of reaction? So the rate of reaction, for example, if you take the general reaction, so the A is the reactant, A is the reactant. Now, these reactant in chemical reaction, they are converted into the products. So B is the product. So if any chemical reaction, the reactants are converted into the products. So in these chemical reactions, generally we show in by the graph. So this graph, this is the y-axis. So this is the y-axis. Y-axis taken the concentration, and this is the x-axis. X-axis is the time. So what happens in the chemical reaction? That initial zero time. So the reaction is not starting. dotted at all. So this the concentration of the A. So the reactant concentration is more. Now, so the reaction is going on at the time T. So that is the AR conversion to product. So A concentration decreases. And initially there is the no products. So products concentration is the 0. So that is the concentration of the products increases. So these in the chemical reaction, so the reactants concentration decreases and the products concentration increases per unit time. So this point, so the cross section point here, half of the reactants are converted to the products and the half of the reactions are formed in this reaction. So the time for this is the T half, that is the half life period of the chemical reaction. So this point, that is the half of the chemical reaction, is completed. So this the definition of rate of the reaction, so that is the decrease the concentration of the reactants or increase the concentration of the products per unit time. So that is the rate of the reaction. So the rate of reaction for this equation, so we already discussed, that is the A gives B. So here A is the reactant and B is the product. So the rate of reaction with respect to A, so that is what happened, the concentration of the reactant A in the chemical reaction, the concentration decreases. So that is we put the minus sign, so that is the dA by dt with respect to reactant A. And the B is the product. So the product concentration increases in chemical reaction. So we put the positive sign and dB by dt. So the rate of reaction with respect to reactant A with respect to reactant B. So if you take the general equation, so this is the general equation, that is the x moles of A and y moles of B is conversion to the m moles of C and n moles of the D. So for this general equation, how can you write the rate of reaction? Here x moles of A present in this reaction, but the rate of reaction expressed for only 1 mole. The rate of reaction always for 1 mole. Here x moles of A is there. So now, so for x moles, what is the rate? That is the dA by dt. This. For rate of reaction with respect to A for 1 mole. So the rate, that is the, for 1 mole, that equals to minus 1 by x dA by dt. So we can write the rate of reaction for 1 mole. So that is the for x mole. So that is the 1 mole. That is the 1 by minus 1 by x dA by dt. So similarly for y moles of B, that is the minus 1 by y dB by dt. Here m moles, that is the plus 1 by m dC by dt. Here plus 1 by n dd by dt. So this is the rate of reaction with respect to A, 1 minus 1 by x. Here with respect to B, minus 1 by y. Here plus 1 by m. Here plus 1 by n. So for any chemical reactions, so we can write the rate of reaction. So this rate of reaction for general equation. So this example, so they have this 2, that is the example is the H2 plus I2 gives 2HI. So for this reaction, how can you write the rate of the reaction? So the rate of reaction, so these with respect to hydrogen. So here 1 mole, so that is the minus dH2 by dt. And 1 mole of iodine, so here also minus di2 by dt. So here that is the 2 moles of HI. So here 2 moles, so that's why plus 1 by 2 dHI by dt. So the rate of reaction is same or equal with respect to hydrogen or iodine and HI. So with respect to reactants or products, the rate of reaction is the same. And the next another example, N2 plus 3H2 gives 2NH3. So this is the synthesis of the ammonia. So for this reaction, what is the rate of the reaction with respect to reactants and products? So here 1 mole of the nitrogen, so minus dN2 by dt. Here 3 moles, so that's why rate, that is minus 1 by 3 for 1 mole dH2 by dt. And here 2 moles of ammonia, so that's why plus 1 by 2 dNH2 NH3 by dt. Here the rate is always positive, that we put this negative sign or positive sign, so it indicates that is the minus, the reactance concentration decreases. Here the positive sign, the increase the concentration of the products, but the rate of reaction is always positive. Next, the units for the rate of reaction. So by the definition, so what is the rate of reaction? Rate of reaction is change in the concentration. So that means decrease the concentration of reactants or they increase the concentration of the product. So change in the concentration by time. Okay. So the concentration by time, that is the concentration time inverse. So now the concentration, it is the moles per liter. Here moles per liter. So the time second inverse. So the time is taken in the minutes. So that is the moles liter inverse, minute inverse. Here moles liter inverse, hours inverse. So the time is taken in hours. So the next one is, so the liter, it is the expressed in another units. So 1 liter equal to decimeter cube. So the decimeter minus 3, and 1 liter is the 1 cubic centimeter. So that is the Cc power 3. So these are the units for rate of reaction for in the different forms. So thank you very much.